Okay, so we're going to go ahead and get started here. Today is May 25th, Saturday. It's 12 o'clock Pacific Daylight Savings Time. Calling in from Spokane, Washington. And we have Eric Dollard and a couple other guys on the team who will be giving doing some slideshows of some of the work that was done down at EPD Labs down in Nevada. EPD Laboratories, Inc. is a Nevada 501c3 nonprofit organization, which is solely funded by donations. I want to show Eric's website here really quick. Okay, so on Eric's website here, this is ericpdollard.com. And in the main menu bar, there's a donate link, which takes you here. And the organization is funded by donations. No matter how big or small, these are what pay the bills and help these projects move forward. There's a PayPal donate link here. There's also a check or money order link here. If anybody sends checks to that address, then I just notarize them and or endorse them and send them down to the bank in Nevada. We do also accept Bitcoin. I found out there's a few $100s in there when I checked that. Or somebody actually checked that for me a couple weeks ago. But most of the donations come in by PayPal or check or money order. A lot of the bills go up, like, insurance and everything else, getting to going up year by year. It also pays the bills, not only for the building, but a lot of the leases for the land where some of these projects are done. And little by little, you're gonna see some of the projects that have been going on down at EPD Labs, and these donations also to help pay for some of the travel and food and lodging for some of the guys to come down to Tonopah and work, as a team effort to knock out, projects in chunks. There's another one coming up here next month, and any donations that come in will be helping to make that possible. And I'm sure Eric and especially Justin will be kind of going over the agenda of what's going to be going on there. Also, a lot of the books and videos by Eric and what's happened at the conference over the last 12 years are available on emediapress.com. You can come here, you can mouse over shop, and then you can click on any of the years, for the videos or any video that comes up. For example, you can scroll down and you can see one of Eric's video presentations here, History, Theory, and Practice of the Four-Phase System, which there's little information out there on what Tesla was really doing, but this is a definitive presentation on that topic. You can scroll down and you can see Eric's name here in a category. And if you click that, it'll bring up a lot of the presentations just for Eric. So you can find presentations just by author or by conference year and so forth. So we're going to go ahead and skip right to Eric. There's a presentation dealing with some overhead lines.
So basically, what I'm going to be showing is the Alexanderson project, which is a VLF system, which means that it operates between 3 kilocycles per second and 30 kilocycles per second. And its position is with VLF, and then there's ultra low frequency, or ULF, which is 300 cycles per second to 3 kilocycles per second. Then there's super low frequency, or SLF, which is 30 cycles per second to 300 cycles per second. And then there's ELF, which is 0 cycles per second to 30. So right now, Griffin is working on the ELF, and here we're working on the VLF. So the advantage of the VLF is starts to get outside of the gangrene energy spectrum. The ULF and SLF is pretty much totally jammed out. So receiving anything has to be done in very remote wilderness locations anymore, even if that would help. It's hard to say. So basically, Western Electric and Bell Telephone Laboratories in the 50s developed what's called the Type OA carrier system. And this operates between 3 kilocycles and 30 kilocycles, actually a little beyond. And it's based on an open wire transmission line plan. So that is essentially what we're using as the Alexanderson system is the OA carrier system, but instead of it transmitting multiplex telephone calls, we're using it to receive the noise that's normally rejected in those telephone calls. So this is a basic Bell telephone description. It's kind of small for the screen, but at any rate, there's a drawing there that shows you the basic voice frequency open wire configuration, and then go to the next page. Oh, there you go, that's better. So that's the spacing and the cross arm sizes and the types of insulators and what have you. Of course, none of this exists anymore, but this used to be how the telephone signals were carried from the central office outwards to the subscriber. All that is pretty much completely eradicated now. So whatever is left standing in the desert is we're resurrecting into this Alexanderson system. So if we go to the next page. Okay, and if you could expand that again.
Just a second here. Okay.
Can you expand that one like you did the other one?
Yeah, which part do you want me to zoom in on?
Just kind of in general. Let's see how it works out.
Can you see that zoomed in more now?
No. But at any rate, this shows the different type of circuit configurations. As the frequency goes up, the pairs need, there you go, the pairs need more and more isolation to keep them from cross-talking to each other. So the one in the middle, that's pretty much the configuration that we're basing the antenna system on here. So this is what either what is already existing in bad repair is being restored in some parts of the desert, and then in this particular part of the desert, we're completely rebuilding a cable TV transmission line from a remote location to the town of Tonopah to work in this configuration, getting the hardware from the smashed remains of this stuff out in very deep wilderness desert locations. So we have to go on these excursions to find this stuff in very rough territory and then gather up the bits and pieces and haul them back. And then that's what we're building the antenna out of. And this has been going on for almost a decade now. It's a lot of work. But we're starting to get to the point where we're getting a certain level of completion. So I think let's go to the next page.
Okay. Can you see that image?
It's still the old one.
Let's see. Sometimes, okay. Is that the next one?
There we go. Yeah.
Okay.
So this shows the frequency response of these type of conductor arrangements. This is for solid copper, but we're using pretty much copper weld. So as it points out, when you get to frequencies above 10 kilocycles, as Tesla discovered early on, that you're leaving the realm of what can be regarded as electronics, and you're getting into the electrical, and it's another type of world. And the normally taught ideas of conductivity and electron flow and all that are no longer valid. So basically, we're dealing with this not as an electron orientated project, but an electric field orientated project. So we can go from here now to the first drawing that I made.
Let's see.
These are more of the circuit characteristics, which are not applicable to this particular video.
Is that the drawing? Let's see.
No, it'd be one of my drawings. It'll probably be about 5 pages beyond. There we go.
Okay, do you want me to zoom in on part of that?
Yeah, let's make it like a little bigger and center it possibly. Let's try to get it all at once.
Okay, it's kind of hard because it's
Yeah,
tall.
yeah, that's pretty good right there.
Okay,
So what we have here is we have the cable TV shack where the receiver is going to go in this present configuration. And to the left-hand side, those are the pole numbers. So basically, there's 55 poles total. And it's a little over 2 miles long. So this is a rather massive system from the normal ham radio antenna ideas. So the cable TV shack receives its signal from a terminal network cabinet, and then which is at pole 49, and then pole 49 to pole 26 is the antenna section. And then from pole 26 to pole 17 is the transmission line section that brings the signals into the carrier terminal, which will be located at the seismograph mine. And then from the seismograph mine, pole 17 goes to pole 0, where then the signals are carried into town either by leased telephone lines, or we have to use what's called toll entrance cable, because running open wire lines on poles into town is kind of difficult and very susceptible to interference. So this basically is the overall plan of what we're building. Not, of course, not a lot has been up yet, but we do have to. Oh, let's see. It was pole. We have the green or the pole pair, the one in the middle, going from cabinet number 1. We have that now goes out to pole number 42, I believe. So we have enough, and we've already shown some of that now we're ready to start receiving. And as this system develops, so the pole pair is going to be developed all the way to pole number 26. And then as this develops, when we get this thing on the internet, then the signal, of course, will develop also as time goes on until this turns into a full-blown Alexanderson system. Okay, let's go to the next page. So this is the antenna section. I don't know if you can turn that 90 degrees or not.
yeah, let me see if I. The zoom controls are in my way. Oh, let's see. Here we go. Had it turned. Can you see that now?
There we go. That looks
Oh,
good.
yeah, hold on. There we go.
So this is the actual antenna structure. It goes from pole 26 to pole 49 and is 4,800 feet long. It's divided into 4 loading sections, and it consists of 3 pairs. 2 on the outside are carrier pairs, and the pair on the inside is the pole pair. The crossing points are what are called transpositions, where you have to keep turning the pair over and over and over so that one side of the line is not picking up more of something than the other side of the line is, and then not canceling out in the repeating coils. So basically it's kind of like a twisted pair. And then the blocks are the networks, which are a key element in the Alexanderson system that basically modify the phase of transmission. So the objective in the Alexanderson antenna is to create an antenna that has infinite wavelength, so that there's basically no propagation effects from one end of it to the other. Everything operates in phase conjunction. So right now we're only concerning ourselves with the center or pole pair system, and the networks will basically just be jumpers to start with until we can get more cabinets and what have you. and start building networks. So this is the primary objective at this point, is to get this antenna system built to the point where it can start to receive and be manipulated to start doing various experiments, and then the networks will be inserted as time goes on. Okay, so let's go to the next slide. Okay, you have to turn that again. This is basically a schematic of the Alexanderson system. Now, this is an improved Alexanderson system. It's not exactly like Alexanderson's. This is what I developed in Landers, and it turned out to work quite well. Unlike the Alexanderson system, this is a wide band system. It can transmit as well as receive over a bandwidth of 10 to 1, which the original Alexanderson system was incapable of. One of the difficulties here is the ground, so-called grounds that are used for receiving are not really grounds anymore. They're antennas implanted in the earth. So conductivity is to be avoided, and particularly anything involving corrosion or electronics, or because corrosion and electron flow and those type of things tend to intermodulate and create frequencies that are spurious and give false indications. So basically, these will be 60-foot holes bored in the ground, and then there'll be a probe that goes down inside a plastic pipe filled with dielectric fluid of some type, and then that will be capacitively coupled to the earth, and the network, the fifth terminal on the network that it's connected to, will make the impedance of the system such that communications through that capacitance will be easy, because we can't get a lot of capacitance, so the impedance is going to have to be high. And then at the terminal end on the left, that one has an actual earth ground, that's conductive ground, and that's what we just got done building, Connor and myself, or at least it's nearing completion. So this is the primary project right now. So basically, this will start off just as a pole pair being used as an electrostatic capacity to the ionosphere for receiving outside of the Earth, even though there is a mutual factor between the inside of the Earth and the outside of the Earth that will join on this antenna structure. So essentially, it will still be receiving somewhat from underground, but it'll be mostly overground. Okay, let's go to the next. Okay, turn that. Okay, now these are the transposition plans. These are rather difficult. So basically, going from pole 26 to pole 17, that transposition plan is shown here. There's several complications with these transposition plans. The interfering power lines are on one side, and we have to come up with a transposition plan to reject against that. But also, there has to be a transposition plan where one pair doesn't cross talk to another, so that one channel of reception is receiving the other channel of reception to some degree and causing a crosstalk. And then the one on the top goes from pole 0 to pole 17, and that one directly parallels the 12 kV power line, and would be loads of interference from that. So again, the transposition plan there is such to compromise between such a plan to minimize crosstalk and such a plan to minimize interference to one side of the antenna. We'll probably start off using a telephone cable and not open wire line here to cut down the cost and difficulties and what have you, but it is it's supposed to be open wire all the way into town. Okay, and I think there's one more diagram. Okay, turn that. These are our basic cross-arm plans. So the one from the cable TV shack, the cabinet 1, is the 4-foot arm with the 18-inch pole pair spacing. The transmission cross arms from pole 26 at the end of the antenna to the carrier terminal in the mine will be 2 carrier pairs on a 4-foot arm, even though there is a possibility that there will be a pole pair and it'll be on a 6-pair or a 6-foot arm, but that's not quite determined yet. And then the entrance cross arm, which goes from pole 17 to the carrier terminal in the mine, is shown on the bottom. And that is orientated for minimum crosstalk between the pairs. So basically, the 10-foot arm on the top is an antenna configuration, and it's designed to be influenced by what's around it, being that it's an antenna, but the 10-foot arm on the bottom is designed to be the exact opposite. It's designed for transmission, but to be impervious to any kind of external antenna currents or antenna interference. So basically the system is divided between the antenna portion, which is susceptible to the VLF signals we want, and unfortunately also susceptible to the gangrene energy. And then the other ones are transmission arms, and they are not susceptible to either, but the intensity of the gangrene energy is such that we'll never be able to totally get it out of there. So we'll have to use some kind of cancellation techniques. So I think that, is there another diagram? I think that pretty much covers it, but let's make sure. I think that's the last one.
It is.
Okay.
Okay. So do we, anything else you want to cover, or should we go to Connor?
Yeah, Connor's next. Yeah.
Okay. Let's see, Connor, if you want to go ahead and unmute yourself.
All right, can you hear me?
Yeah, let me get this set up here.
My name's Connor Fisher. I got involved with EPD Labs after this last Energy Science Technology Conference. Just giving an update on work done from April 30th to May 8th this year. So to start off, just showing a spool caddy that I assembled, which will be used to support spools of hard drawn copper, which will ultimately be paid out to the antenna structure. We didn't get to that point, but we're just establishing some level of preparedness for that. Okay, here, this is the corner ridge pole. I believe it's pole 45. Basically, we had a section of field telephone wire that was damaged from this pole down to the next pole down the hill. So this just shows that we replaced that damaged field telephone wire with copper weld conductor. This is just another view of the same pole. And this is the next pole down the ridge, presumably pole 46. So we're still going to need to replace the field telephone wire from this pole down to pole 49 that Eric was referencing, where the terminal cabinet is located, which is, I believe, the intersection point between the transmission structure and the antenna itself. Okay, so now we've jumped over to the mine where the seismic transducers are located. This is just outside of the seismograph station. What we're trying to do is put in the infrastructure necessary for the power company to establish permanent power at the seismograph station. So these are just some images showing the cross arm arrangement and backer board. There's a nice sunset out in Tonopah. Again, this is the backer board, which you can see here. We've mounted a 240 volt, 60 amp fusible disconnect switch and associated meter socket. This carries up to a weatherhead, and this is ultimately where the power company will, connect us at some point in the future. Now, of course, we're going to need to establish some capital for them to make that connection, and I don't want to speculate on price, but I imagine it's not cheap. Okay, now we're coming down the hill. I believe this is pole 26. Is that correct, Eric?
Yeah.
Yeah, so this is pole 26 at the end of the antenna structure. We were working on establishing a grounding network here. So you can see dug trenches at approximately 24 inches of depth. Now, the grounding network that we are establishing was twofold. We have the static ground composed of 4-gauge bare aluminum wire, which will be terminated onto lightning arresters on top of the pole. And then situated on top of that is insulated 4-gauge aluminum wire, which makes up the grounding network for the antenna structure itself. So this is again just showing trenches being dug. There was some grounding rods already in place that Eric and Justin had established at some point in the past, so we're just digging out to those grounding rods. Okay, so here you can see the bare aluminum conductor, the static ground for the grounding network, and next to it there you can see a bag of Epsom salt, magnesium sulfate. So we added magnesium sulfate to the soil in order to increase the conductivity of the localized region. Eric, after referencing his radio engineer handbook, determined that magnesium would be a sufficient electrolyte to add, since it tends to sacrifice itself to the aluminum and preservation of the aluminum conductor. So again, this is just showing the static ground getting put in and, adding the magnesium sulfate and watering it into the trenches to increase the conductivity. This just shows that we have parallel lines of that bare aluminum conductor. Here is where all the static grounds jump up to the guy anchor pole situated in close proximity to pole 26. These images just show that we took the time to actually, reconcile the frayed ends of the static ground, being that if enough charge were to build up on the ends of those, on the tail ends of the static ground, there's a potential that it could short out on the ground rods in nearby proximity. What I didn't show is we actually put PVC sleeves over that to add further protection. Here's Eric inspecting everything. Okay. So at this point, we've backfilled the bare aluminum conductor, the static ground, and we're putting in the insulated aluminum conductors. There's somewhere between 3 and 6 inches of separation between the static ground and the grounding network for the antenna structure. Here you can see we brought tail ends of the insulated conductor up at 15-foot intervals so that we can install ground rods at a later date. Okay. Just backfilling with rock and gravel to add structural support to our poles. Here you can see it's all backfilled. We watered all the soil in. We also added a native seed mix to help in the revegetation of the area. Okay, this is pole 26. The image is kind of blurry, but we have the static ground carrying up the pole, which will ultimately carry up to the top of the pole. Adjacent to that, we have the insulated conductors for the grounding network, which will be terminated in a box at a later date. This just shows that we took the time to protect the tail ends of conductor that are coming up out of the ground, so anybody ripping through the desert on their ATVs don't mess up our grounding network in any way. And yep, that's pretty much it. So it's just an update on the work that we did in May.
Do you have any comments on it, Eric, or do you want to go straight to Justin's?
Yeah, let's just go to Justin.
Okay. Hey, Justin, if you want to go ahead and unmute yourself, you should be able to share your slideshow.
thanks everybody for joining this call. Connor's great presentation. I appreciate that. And it's even more elaborate. I didn't know the extent exactly to what all you guys got done. But that's great. So I'm going to kind of go. I don't have a slideshow per se. What I have is kind of so I've just got a file. I'm just going to share, basically random photos through the file. The diagrams that Eric, for anybody who doesn't know, and just a review for people who do know, the diagrams that Eric's shown of the Alexanderson antenna, what we're working on is, as Eric said, basically a historic reconstruction of equipment that the Bell system would have operated. And so, here's an example of that. Can you guys see my screen okay?
Yeah, they're small and blurry, but they're there.
It may take a second for it to catch up. There might be a video latency.
I'm glad you got that 3 cross-arm one.
Yeah, can you see the blown up version that I've just expanded my screen?
Not yet.
No, you're just still seeing small thumbnail version?
Yeah.
Well, that's unfortunate. I don't know how to use this MacBook to do photo sharing, to show a slideshow.
I'd imagine you double click or something and it should come up. You need to reshare the screen for the photo sharing.
I'm screen sharing. I don't know. On my screen, I'm looking at a full size image. I guess you guys aren't seeing that. Screen sharing is paused. Let's stop screen sharing and we'll try again.
Okay.
Going into okay. So if I click share.
There we go.
I see it now.
You guys got full screen?
Yep.
Okay, awesome. So I still got to go file by file. But so what Eric was describing about old Bell system technology, we're basically rebuilding. This is a historic rebuild, and the purposes of which are for reception. We're not trying to transmit voice long distance like the Bell system was. The Bell system actually went through great effort to reject the noise and interference and have only clean end-to-end voice communication. That was the purpose of the phone line. What we want is the analysis, the ability to analyze the noise. So we're putting up facilities that look just exactly like this. And Eric's shown in his documentation, the project is scalable. What we're proposing, what we've built thus far, and what we're proposing to do in next steps in the near future, this year, is much smaller versions of what you see on the screen currently. So I'm showing this. This is some of Eric's historic photographs that he actually took back in 2013, 2014, possibly. This is Eric, correct me if I'm wrong, but I think this is out by Susanville.
Yeah, so basically, if we have the money and the space and what have you, this is what the Alexanderson system would be based upon, because it would give enough pairs to use some as capacitors and some as inductors and what have you. So most of this stuff is basically abandoned, and the challenge here is to try to figure out a way to get the money and deal with the impedances to be able to salvage this stuff, to get the materials before it just gets all vandalized or whatever happens to it. So, but that's kind of beyond our means right now. So whatever falls to the ground and is scattered, we can clean that up. But as far as any major line removals, we could do it, but the bureaucratic element and the overall cost are prohibitive. So we're making do with what we got.
Right, we're making do with what we got. And so what we've got is we've Eric's talked about the extent of this line that we have. This is our granted right-of-way line. And we've been at this, Eric and myself. Now Connor's engaged. This is the historic cable TV. This was historically used by the cable TV company in the town. And you can see our shack in the background. If you guys can see that, where my cursor is tracing. This is a good representation of kind of the scale. This isn't even all the way back to pole 26. But this gives an idea of what facilities we possess. So I've shown the historic 3 cross arm installation out by Susanville, sort of an idea of what we could do if funds were unlimited. We had all the resources in the world. We can scale this project even within the facility that I'm showing here. There's initially what Eric and I set out to do was to put up the outside pairs on a section of this. This is actually a different facility that we repaired and recovered for some same purposes effectively. Here we go. This is a photograph of end to end. So this shows pole 26, and Eric and I initially put up about a 1,500-foot section of this in 2016, roughly. And you can actually see the field telephone wire stretching off of the outside pairs. This is the same field telephone wire that we've experimented with, which does not work. We have come to the conclusion that this is not the right wire to use, but we're trying to save cost. We're trying to keep costs as low as possible. So we've implemented this wire as a cost-saving measure, and we finally just accepted the fact that it won't support itself. So when Connor was out recently, he repaired with Eric some of the damaged line, and we have a section of line now that is up, that is terminated, that is functional. So I'm going to show some photographs of that for context. So this is the terminal pole that we're talking about, where we've connected currently. This terminal pole is the junction point between the antenna section of the line and the transmission section of the line. Transmission section of the line carrying on up to the shack, the terminal shack. But this is the point in the line right now where we have the ability to connect to the pole pair version of this antenna that Eric has illustrated. So we're starting small. We're starting with a functional model, something that will actually make noise. And we're looking this session to bring that to reality at the shack. So here's an example of the work that we did last session, which was October into November of 2023. And after Connor came out and worked with us, we were able to get this section of line. Oh, I think it's again about a 1,500-foot section that's currently up. And it terminates in this cabinet. And all this equipment that you see in the cabinet in front of Eric, this is all test equipment that we bring out to the field when we want to set something up. So this is for testing purposes and demonstration only. This is not the way that this cabinet is intended to be configured. So what we propose to do this upcoming session is put repeater coils into this cabinet and utilize the section of antenna structure that we've built along with the transmission line to bring those signals to the shack. And we've shown a number of photographs in some of these calls. This is currently the equipment in the shack. And as you can see, there's a left-hand bay, one rack bay that's completely empty. And that's where the reception equipment is intended to go. This as well is quite scalable. So for the purposes of demonstration this upcoming session, we're going to provide some kind of a battery power system. Probably my 18-volt cordless power tools is what we're going to use, we think, this session to power the reception equipment that's going to connect to the line. So we'll configure that however we do for the purposes of demonstration. Ultimately, we're going to continue to upgrade the system as we have funds available to do that. So we have a 12-volt solar power system here. You can see in the photograph the battery at the bottom. and charge controller, switch panel, fuses and such about midway up the rack. And this currently is our voice repeater and our weather station. We've described some of those facilities in the past, but the goal for this upcoming session will be to terminate these signals at the shack so that we've got something that makes noise. We're really keen on doing that. And we've demonstrated before with the tactical equipment. We have some video to show as well of using this equipment to be able to connect to the line. And that's what we've done in remote field applications where there's a section of line that's still standing, previously operated by a Bell system. None of those facilities are used anymore out in the Mojave. And so we've used this same equipment to do demonstrations on remote facilities that are not our right of way. But what I'm showing you currently is our right of way. So for this upcoming session, we're going to go out there, meet with the crew. The plan is to meet with the crew, and Eric has a whole variety of different things that we're going to be working on and collaborating on. So, so there's some aspects where the group will be, how would you say, divided into, teams to tackle certain goals. And there's some things where we'll all work together. So like Connor and I will particularly be focusing on whatever outside plant or building maintenance facilities. That will be more our end of things. So what Eric and I have spoken about recently is the idea of, like I said, bringing everything up to the shack, and for this session being able to terminate in the shack something that makes noise. And Eric, do you want to talk some about the equipment that you want to implement in the shack? I believe it's the 37 Bravos that we're going to use initially.
Yeah, it's a 37 Bravo telephone transmission test set built by Northern Electric. Used to be used widespread in the defense communications system back when I was in the Navy. And I have some of those now that are being brought up to spec by Griffin. So Griffin will be able to show a picture of one of these. They're very versatile. They have a number of filters. They can, they basically are good down to about a picowatt. So we've got plenty of sensitivity. And an indicating meter and an output for a chart recorder and what have you. But being telephone equipment, of course, they're positive ground. They're not negative ground. So that means we have to have another system. So we'll probably just start off with the portable battery. And then the objective is once the signals are made to an acceptable level and bandwidth and a minimum of interference, then we will put this on the internet so that the earth signals will be receivable by anyone that has the means to get their computer to go on the website or what have you. That's kind of beyond my end of the deal, but we'll probably start off with some China junk microwave link on the internet and then upgrade that to get the Chinese completely out of it and make it American again. And then it'll be reliable and there'll be no Trojan horses living inside. And it will be EMP proof like pretty much everything in this system. So that's what's going to have to go on in the shack. So basically, we have to come down off the mast of the shack, lightning arrestor, and then go through the electromagnetic bulkhead and into the terminal equipment. So, and then we will also plan how we're going to go about setting up the microwave link. So this will be one of the things. The other high priority project is we're going to get the telluric test platform and the 2 megacycle Tesla transformer set up more permanently and get that. So that will also be on the air all the time, just like this will be. So that's what Griffin and I will be working on. So we got to take some Navy equipment and remove the power supply and attach that to some other Navy equipment and put in some coax and what have you. And we'll probably do a range test to the PRC-47 in my car. And then we have some oscilloscope and what have you, things to work on for the gangrene energy study. So being that the gangrene energy has basically wiped out any possibility of us doing any research in various bands, then the only thing we can study is the gangrene energy itself, which has reached absolute outrageous proportions. I don't know what to do about it. Something has gone berserk in one of these gas stations close by here with all the China junk tech in it is cross-commutating, and it's short-circuiting the power line for 1 microsecond intervals, which of course does not blow the circuit breaker or what have you, but it is just transmitting hellacious RF everywhere, which is just completely jamming everything out. And it's basically 3 times the amplitude of the associated power frequency signals. So I don't know whether to complain to the power company or the FCC, being that there's no laws anymore, it's just whatever. So I don't know, but it's very disturbing. So this is, and then we're going to put up electromagnetic sense antenna to put a spectrum analyzer on to get a broadband observation of the gangrene energy. So basically in the upcoming work episode, we will do 2 presentations. We will do one on the implementation of the Alexanderson system pole by pole with diagrams and what have you. And we will also do one on gangrene energy and show you some of the things I was talking about that are getting progressively worse to the point that kind of makes you wonder what in the hell's going on.
Okay, so, and I'm sure that you'll cover that a little bit more with Griffin, some of what you just were covering there, Eric. I don't have photographs of, so I'll just wrap up my presentation and then I'll put it back to the group. But just to kind of conclude and wrap up on what we've got built so far. So Eric just said a key thing, which is that this session, when we're out there, we're going to do quite a bit of documentation. And we've done pieces here and there, but a lot of people seem to still have some confusion about what the entirety of the system is that we're trying to build and how it all ties together. And basically everything that we've talked about thus far in the call, all these facilities, the data from any individual element can be compared to the data that we're receiving from another element. For example, the Alexanderson antenna, you compare what you're picking up on that antenna to the seismograph mine and what's physically happening there locally that's being picked up by the mechanical seismograph. And then similarly with any kind of antenna or spectrum analyzer analyzing the gangrene energy, all these phenomenon will be compared as a system. This will be an integrated system. So we're not just talking about one random thing and another. They're all associated in one way or another. For the sake of comparison. So this picture, I'm just going to kind of conclude right here on this picture. This is actually 2016 when Eric and I went out with the field telephone wire attempting to do the original this was the first wire that we put up. These are poles that were largely installed by the cable TV company. We acquired this right of way. We have granted access. This is our right of way, our hilltop shack. We put these cross arms up. This it was all salvage material basically. And so it was an experiment. And this first round didn't work. And so the pole 26 that Connor was showing the grounding network of is that will ultimately be our soon, hopefully within the course of this year, our intention is to go end to end with the pole pair. Now, not the outside pair, what's shown here in the picture, but with in recent sessions within the last year, we've been focusing on just the pole pair. And what we want to do is, if we can basically continue to fund these work episodes, then we can make some substantial progress within the course of this year. And we have made some substantial progress last year. And I just want to reiterate what Aaron said and what Eric has stated, that this is all done by donations. So at the rate the donations come in, basically sets the tempo of how fast we're able to move through this project. Historically, I've volunteered. Everybody in this group has just put their own time in, and maybe we can get some costs covered from time to time. I'm looking to step up the pace. And so to do that, I'm really interested to figure out how we can fund basically all the participants and pay them a wage, pay me a wage, pay Connor a wage, pay other people who are working on this stuff and building this. So just again, want to remind everybody, this is completely donor funded. We do this on your support, and at the rate that we're currently bringing in support, it looks like we're going to be able to have, a productive session. Might be a little bit of a short session this time, but we'll see. What we're going to do this session is, like we've stated, we're going to bring the signals up into the shack and terminate them there on some kind of equipment for a demonstration. So that, and we're also going to demonstrate, Eric and I and whoever else is there can go out and really talk about, with Eric's diagrams, the extent of this Alexanderson antenna and how it can be built, in what phases it can be built, what value it will have in its various configurations, which is really, it's based on who wants to fund us, how far we can go with this thing, and and how long Eric lives. So we're making a big push this year, and we're hoping to get these signals, like Eric said, on the internet by the end of this calendar year. And there'll be a couple of different ideas with that, which maybe Aaron and Eric want to speak to, what potentially some of the plan is with that. We're talking about, it's all just in the consideration phase. Obviously, we've got to get the signals beamed down from the shack and connected to the internet, however it is that we do that. And then we'll make them available for research purposes, obviously, and to promote our whole operation. And then we're also considering that there might be a subscription-based, access that'll also help to fund these operations moving forward. So that's kind of, that's my presentation, my update on everything that's going on. I'm really looking forward to meeting the crew out there, working with Eric this next session, which should be upcoming in about, well, we're projecting, month of June, we'll be back out there again. So with that, I think that about covers it, and I'll turn it back over to the group.
So I hope, people really need to realize that this is literally the largest scale Tesla type project / experiment going on in the world today, the largest scale, and nothing else comes close, at least for what the public knows about. Who knows what's going on behind the scenes, but for people to be able to have open source access for the most part to everything that's going on, that I don't think that there's anything else that can really touch this. And like Justin is saying, that this does take money to move these projects forward. And with some of the pictures that you've seen, you can see that the money is going exactly to furthering this type of research. On ericpdollard.com, I think you can, if the screen is showing right now, that's the donate page on EPD Laboratories Inc.'s website. And any donations by PayPal are appreciated. And especially if anybody can send any checks or money orders, here's an address here in Spokane. Those come to me, and I sign those and send them down to the bank. And this is what helps to pay for this this type of research. I think a good goal for over the next month, if we were able to raise between $10,000 and $15,000, that would help make it easier for this next episode. But it would also help us be prepared for a next episode in a few more months after that. Possibly by maybe the end of summer, something like that. Does that sound kind of on track, Eric?
Yeah, that's if this is going to happen in my lifetime, these sessions have to be once every 3 months. So that's what's requiring, that there be enough money to pay the people that are working with me on this, because when they're working on this, they're not working their job and they're not making money. And that can be problematic. So, and none of this is cheap. And the value of the facilities, we have another facility in the Mojave that that is much less susceptible to these gangrene energies because it's cleaner out there. It's in an all Delta neighborhood, but we still have a lot of leasing agreements and what have you. But that installation is much more sophisticated than what we've shown. We have shown that installation in the past, and I gave a presentation involving it. What was it called? Electrodynamic seismic forecasting. I think it has the videos of the signal reception and all that. That's a priceless facility. It's 5 miles in length. We have 5 miles of direct barrier cable. We have 1 mile of open wire line and what have you. And I would say that that installation is easily valued in today's economy at $1 million. And we just can't let this stuff slide down the drain, but we can't get enough money to finalize the lease agreements and to finish cleaning up the desert and all the things that we're required to do when we work on these projects. And then what's disturbing is on the other side of the deal right now, over the past couple of months, the average magnitude of the donations coming in per month is only $250. And that doesn't cover the cost of anything. So I've saved up enough money by tightening up here on my own personal expenses and what have you to fund this next episode, which will bring a lot of things to completion and will look good. But after that, there's no money left. And that's one reason why I can't involve the power company to get more power connections or the phone company to get more phone connections, because the question is who's going to pay the bills? And the other thing is the power company does stuff for us if we do stuff for the power company. So there's things that we have to do for the power company to get our old cable TV system off their poles. But that costs money too, even though it's cheaper to help them and then have them help us than it is just to pay them. But as it stands, normally we expect without a trade-off that the power company will want $15,000 to put their transformer in and connect the power to the mine, and that's just simply not available. So this is the difficulty that we're facing. And this week I became 72 years old, so now it's the question that I face is there's 3 things. My Corolla's got 700,000 miles on it. I'm 72 years old, 72 years of age, and society's getting ready to take a squat. Which one will take a squat first? Me, the car, or everything else? It's not a exciting future, but at any rate, we're moving ahead despite.
So, and I do want to mention that the donations are tax deductible. It is a 501c3 charitable nonprofit. Can you see these videos on the screen? Are those visible, Justin? Some of Eric's presentations?
Yep, I can see those presentations.
So, and if you want to learn more about what this project is about and some of the things that's related to it, just by searching the word musical seismograph right here, this is like a 4.5 hour presentation or more. And it's actually about 5 different presentations all in one. And that'll give you a lot of different aspects of this whole project, this electrodynamic seismic forecasting. There's some other keywords you can search in the search bar at the top right of emediapress.com. Like if I search telluric, here's some stuff right here. Telluric radio communication research. That's by Griffin. Eric Dollard's telluric research. This goes all the way back to Landers. So if you just search some of these keywords relating to seismic, telluric, and so forth, you'll see a good handful of presentations on eMedia Press about that, where you can kind of learn, educate yourself more on what this is about. the seismic application is, one of many applications. It's really going to be kind of like a universal test center for all this longitudinal type of stuff that, you've heard that type of terminology relating to Tesla and everything. And this long, antenna line, this is like a mile long almost. So this is, pretty serious scale that, will enable EPD labs to conduct all kinds of experiments, not just the seismic forecasting stuff. You have any other comments, Eric, before we see if Griffin is ready, or hopefully he has a slideshow. If not, he can at least maybe give a verbal.
Yeah, I do want to point out that in the musical seismograph, the amplifier project is also presented in that. And of course, that's something else that we're working on, is to come up with a series of audio frequency high fidelity amplifiers using Bell Telephone Laboratories concepts that never really made it into commercial amplifiers. So that's basically, that equipment is designed now for the first level of commercialization, and it'll probably be kind of expensive, but nevertheless, these amplifiers will literally be the resultant of what you would consider a collaboration between Bell Telephone Laboratories and the United States Navy, which is my engineering protocols. So they will be rather remarkable amplifiers that will be very reliable and operate very effectively and be novel. So we're moving forward with that, as well as these other projects.
And so this is an amplifier that was intended to be a headphone amp of maybe about 1 watt, but it sounds like it's going to be about maybe 5 watts, and it can be used for some of the seismic, what do you call amplification? Eric's done some of that electrodynamic seismic forecasting presentation, but also Griffin has shown some of the simplified method with the antenna over his house, and with pretty low budget, low tech methods, be able to see some of these signals. This amplifier is suitable for amplifying those type of signals, but also music. Eric said you can also hook up a speaker, put your guitar into it, and you can jam away, and you're not going to be able to blow this amplifier, and it's going to be virtually distortion free, and you can't fry it. So it operates on a novel concept that we're not going to discuss now, but there's no other amplifier in production apparently anywhere in the world that has ever used this particular principle, because pretty much every single audio amplifier over the last century or whatever has pretty much been based on the same type of principle. And this will truly be a novel way of amplifying audio in a way that nobody has had their hands on ever. And we're going to be the first ones to do that. Eric has the plans for that. And so we're going to be putting that into production. And that is also going to be a revenue generator for EPD Labs to help pay for some of these projects. Because donations are great. The smaller donations come in kind of steady. The big donations that come in, once in a blue moon. But if we can get, start off with one of these products and put that up for sale, then we can at least have some kind of control over, generating revenue. And that's one of the points to it is, put out an interesting and novel technology that nobody has ever seen as far as audio amplifiers goes, but it's also to help raise funds. Not a magnetic amp. It's completely different. So let's see, Griffin, can you hear me?
Yeah, I could hear you.
Okay, let's get you on a screen here.
Yeah, it doesn't look as though my computer wants to send the attachment to you, so I suppose I'll just have to narrate then.
Okay, so if we got problems with that. Okay, so are you able to do video on your phone without it lagging too bad, or?
I've tried it, it doesn't work.
Okay.
So I'll just have to narrate it then.
Okay.
So,
and then after Griffin, we'll go ahead and open up for some questions. Go for it, Griffin.
okay. So as already discussed, the main plan of events for the next episode to commence in the latter half of June is underway. So around the latter half of June is the projected time frame for myself as well as Hawkes to come to Tonopah and meet with the rest of the group to facilitate and finalize some of these projects laid out herein. So one of the main projects that I'll be working on alongside with Eric is the telluric test platform finalization. This consists of a few different parts. One of the main parts is the upgrading or the reconfiguration of a TCS Navy transmitter. This entails reconfiguring the transmitter so that it could put out more power than is intended. At the present case, it could only put out about a couple tens of watts, but with a new configuration, then we could reach about the 100-watt level. So this, in coordination with the platform itself, will be making some adjustments so that the platform is more rugged and more suitable for long-term operation. And once that's complete, then we'll have a fully functional transmission setup. Now, in the near future, one of the main plans is to facilitate the role of the FCC in acquiring some form of a allocation, which will be roughly around 2 megacycles. Now, this, of course, will not be occurring this time around, but it is something that will be commencing in the near future. And involving that project, we have some other various experiments and finalizations that I know Justin and Connor had covered. So in the meantime, I've been procuring equipment and other materials related for this upcoming episode, as well as other projects that are both related and unrelated to this coming episode. Now, I could touch on some of these other projects that do not necessarily correlate. One is the advancement of the 1A21 radiating beam tube, which I've covered extensively in past live calls, but also at the last Energy Science and Technology Conference. One of the main experiments underway involving myself and other colleagues is the analysis of the tube's emissions. So at first glance, it seems as though that the emissions coming from this tube are a form of X-ray, but when in fact a colleague who's located in Canada has been able to conduct a series of analysis and other tests to indicate that we are dealing with something completely and rather unique. Now, recently, he had let me know that one of the experiments he conducted was a spectrometer analysis test, where he placed the receiving scintillation apparatus in an enclosed chamber that was surrounded by 2 millimeters worth of lead encased in a cylindrical casing. This was placed at some distance away from the tube, and upon analyzing the spectrometer results, he found that despite the intensity of the rays being barely attenuated while being in the lead casing at some distance away, he found that the energy level associated with the measured analysis, which was peaked at around 5 kiloelectron volts, did not correspond with the resultant wavelength of the emission that he was receiving. So in essence, what he was detecting was something not behaving as a regular X-ray emission, but rather something completely puzzling. This has been a series of various analyses and other experiments that this colleague of mine has been conducting, and I await further information from him in the near future. On that same topic, I have also been in touch with a different person who has access to higher end laboratory equipment that could facilitate and see to it the further analysis of these electrodes, which are placed within the 1A21 tubes. I've touched on this matter in the past, that these electrodes experience some kind of a tarnishing effect, which is rather unique to the tube, as well as the phenomenon which is occurring within inside them. So this lends itself to the further analysis of these electrodes, which of course I do not have access to, but through this other colleague of mine, this will occur, and we could further rule out whether or not there is some type of a transmutation occurring or any other phenomenon occurring on these electrodes. So far, progress in that realm of research is progressing at a steady rate, as well as other projects relating to it involving the flat top antenna and other telluric receiving experiments. Now, following some unsettling events with the antenna, which was due to in part natural activity and other matters that I will not get into, the antenna was slightly damaged, but recently it has come up to level, so it is now fully functional. And once the weather permits, I'll be able to conduct a series of needed analysis tests, as well as some other stuff on the antenna, and proceed with the telluric receiving experiments as outlined in the past. So I would say on my end, that pretty much concludes what I've been up to recently. And I do look forward to the next coming work episode commencing in the latter half of June. So I suppose if we could hand it over to any other members of the group, or we could open
Okay.
up for questions.
So yeah, you probably couldn't see it, but while you were talking about the tube, I showed a picture of the spectrum that was discussed. I think it was on a March 30th YouTube video. So if anybody wants to see the presentation or slideshow that Griffin did on that, it's on one of the YouTube videos on my channel, which is youtube.com/Aaron Murakami. And it was March 30th. And I think it's that video that Griffin went into a lot of detail about that. And also Griffin's website, I showed that just briefly, but it's griffingBrock.com. Let me bring that up. I was showing your website also while you were talking, Griffin. Hopefully that showed up.
Okay.
Should be coming up right now. Yeah, so griffingBrock.com. This is Griffin's official website here. You can also donate by PayPal, and he puts all these donations into
There's the 37 Bravo. Go back. Yeah.
right here.
No, over to the right, underneath the 3 chart recorders. Yeah, those. So one of those will be coming out here. Yeah, and that's what'll go in the shack. And maybe if Griffin can manage it, the one below that, the Sierra selective voltmeter, will be very applicable to this, assuming that we can power it off of a battery. But the 37 Bravo is a definite.
Right, and those have been refurbished and cleaned and calibrated, so they're all in functional order. There was only one of the units that did not want to operate well, but that has been corrected. So 2 of the units out of the 3 given are fully functional at the present.
So we have 5 total. So hopefully out of that, we can get 4 of them running with spare parts. I think they're the last of them left on Earth. Fair Radio had 5 of them left, and we bought that out, and probably no more. Interestingly enough, the Navy TCS transmitters are still quite prevalent on eBay for $1,000 a piece. They're not $50 from Fair Radio anymore like they were when I was a kid. But that's the economy for you. That's probably one of the best transmitters to use for this type of research, because they go down to 1,500 kilocycles. For most modern equipment, does not go below 2,000 kilocycles. And then to go below 500 kilocycles, we'll probably at this point have to build all of our own equipment, because that Navy stuff has pretty much vanished from the face of the Earth. That would be the WRT-1. Those are no longer in existence.
Well, you want to go ahead and should we open up for some questions?
I think so.
Okay. If anybody has any questions, at the bottom of your screen or on whatever platform you're using, there's a reactions button. And if you click that reactions button, there's a little button you can click that says raise hand. And then I can go ahead and unmute you. And then you can go and introduce yourself, say your name, where you're from, and who you're asking a question to. And if we can keep the questions and answers kind of brief and to the point and relevant. How does this infinite wavelength concept of the antenna compare to what is being developed with a fractal type antenna design? That's from Ken B in Sonoma County.
No, there's not really a direct correlation there.
Is part of the difficult grounding of your antenna design related to the lack of ground moisture?
There's a number of considerations. So basically, one thing is intermodulation distortion caused by electrolysis. So being that this is operating in a strong signal environment, but trying to pick up weak signals out of it, any type of electrolytic action of a ground rod against the soil or anything like that will generate spurious frequencies. And then the Alexanderson antenna itself does not really like a conductive ground. It wants an inductive ground. So basically, it doesn't want a good ground. If you did the thing on salt water, it probably wouldn't work right. The original Alexanderson design might, but in this case, the advanced Alexanderson design, which is originated out of the unique designs used at Bellina Station KET and New Brunswick, New Jersey Station WII, which were converted Marconi stations. Those, from my studies in Bolinas, it was not they ripped the Marconi ground up and put a separate ground in. So they did not want the antenna operating over a perfectly conductive ground plane because it tended to short out the loading elements. So there were localized grounds set up kind of like star patterns that were not connected together, and they were not connected to station ground. And then at Landers, I found this to be the case, that you didn't want conductivity. So Landers was a good place for inductivity because the ground there was completely non-conductive for the most part, unless you drove the ground rod into the plants of a root or the roots of a plant. It was quartzite, so that was a good inductive material. Here it's mostly igneous rock. It's also virtually non-conductive. So again, that will be an inductive medium. Where we want the ground conductivity is in the lightning and static protection. So those grounds, we're seeking areas where there's a lot of ground moisture. So the ground system that you saw that Connor and I were involved with is an area where the ground remains fairly moist. And if we have the money, we'd actually drill a well and keep that area irrigated, because that would be our point of zero potential with respect to the earth. And the rest of the so-called grounds in the system would actually be buried antennas, and they would have no conductivity whatsoever.
Okay. Ike B, I think you're unmuted there. Go ahead and
can you hear me?
Yeah, can hear you.
Okay.
Where are you calling from, and what's your questions?
I'm in Salt Lake City. First of all, I'm really excited. I randomly checked my email, and here I am. My only experience with your stuff is about a decade ago. I just watched your videos over and over for a month, and I was just I'm a little starstruck here, and I've had about a pot and a half of go juice this morning, so I might not talk right. But I'm just gonna send this in the chat. I was already writing it, but I wish I had prepared. I would have watched these videos if I would have known, and kind of prepared. I only know your stories from memory, but it says, you said, this has been ringing in my head forever. You said the sun is a capacitor, as I remember, and I don't remember your whole story about it, but I've been thinking about that for a decade and thinking about it. But my question was, that maybe I didn't understand about your story was, do you believe that a star is born with all the energy it's ever going to have, or do you believe that it continues to derive energy from somewhere around it, the environment? Or do you remember that?
It's like an electrostatic transformer. It's taking induction and converting it into energy. So it's not like the sun's going to
Induction.
burn out or use up its fuel. That's all that physics gobbledygook. Like
Yeah.
the Earth is going to cool down and all that is the Earth is actually kept warm by cosmic rays, Tesla cosmic rays, like the stuff that Griffin's generating. So
The
there is never
beautiful
going to
ones.
cool down, and the sun's never going to burn out because it's not burning any fuel. It's a converter from like one dimensionality to another. And in fact, a lot of what comes out of the sun cannot be considered energy in the strictest sense. It's not energy until it's intercepted by the Earth.
Okay.
So that kind of
Well-
goes along with the notion that you can't see the sun or the stars in outer space, which has not been absolutely verified, but there were
And that's what I
there
thought
were
you
there
said.
were conversations with astronauts or the early astronauts, and they indicated that that indeed was a problem, that once you get free of the Earth's envelope, so to speak, that only reflected light exists. There is no direct light. So that would kind of flush down the toilet bowl the idea that it takes so many light years for light to reach a star to the Earth. That is no longer something that you can take as an absolute certainty. And there's no way to prove otherwise, because how are you going to reference the transmission and reception? But these are kind of the things that we're getting into with the radio experiments and the telluric stuff and all that. Here is the idea of velocity and the velocity of light and all those relativistic concepts. They don't apply anymore. They just get in the way, just like the electron theory will lead you in the opposite direction of how electricity really works.
So this kind of leads into my next, another question. It sounds like it's related, but are you willing to speak to Father Farnsworth's work?
Well, Farnsworth's work is kind of related in that he created a star in a bulb.
Well, excuse me, there was a specific thing, a story that you told about a device that he had created, and I don't know if I'm remembering correctly, but a device that he had created that looked like a vacuum tube, an old vacuum.
Yeah, it was
And
called a multipactor tube.
Yeah, and
And
did you say it worked on
created
resonant harmonics?
it created a star in the middle, and
Yeah.
and out of that star, more electrons radiated outwards from the star than came in from the photocathodes. So basically, the thing became what he called a virtual cathode, and it was emitting electrons, but the electrons were not derived from any electrical conductor or current source because it was an empty vacuum tube. And allegedly, the tubes powered itself. In other words, it could be removed from the source of excitation and it ran on its own for a while.
Oh, and also the church. I loved your story about the church and the organ, and I don't need you to speak to that, but I really enjoyed that story. And I guess the last question I have is just an idea that I've had. So if it seems like the universe behaves as if its contents under pressure in the way that it inflates, why don't we conceptually see the universe as contents under pressure and kind of treat it that way? So gravity becomes a push rather than a pull.
I can't offer any ideas on that. That's out of my field.
Yeah, it's kind of like a daydream that I have all the time.
Yeah, you can keep
Anyway,
on with that stuff. Yeah.
you know what? I really, this is just a joy to me. I never thought top 10, that question, who would you want to have a beer with? Eric Dollards, he's up there. But thank you very much. And Aaron, thanks for helping out. And just for years you've been doing this, and I think it's a great thing.
Sure. Thank you. You're welcome.
All right.
Okay. Thanks, Ike. So, hey, Eric, on the topic of the sun. So the call a week ago was, if that was last Saturday, was canceled because of the solar flare activity. I know everybody from ham radio people to a lot of digital, especially a lot of wireless, was interrupted by all the solar stuff kind of going on. Do you want to mention a little bit about how these cycles happen in threes every so many days, and that we're going to be
Lost your audio. There you go.
Yeah, and then what's going to happen over the next, two months, or how these cycles kind of play out, how they peak and go down and whatever.
So basically, nominally the sun rotates on its axis between 28 and 32 days, depending upon where you're at on the sun. So if an active region appears on the sun, it rotates with the sun. So basically, this flare that occurred about, I would say probably 2.5 weeks ago or something like that, was quite significant. Nothing absolutely outrageous, considering now that flare put us on the doorstep of the peak of this solar cycle. But it was very, very, very powerful. It was an X-class flare, an X8, which is pretty significant. It resulted in a disturbance to the Earth's magnetic field of a K index of 8, which is the Richter scale of the magnetic field. It's a logarithmic scale that goes from 0 to 10, so 8 is rather substantial, and that's what induced the aurora. So basically, the aurora and the K index is Earth's response to being hit by a piece of the sun, which is ejected from the active region on the sun. So that active region now is due to come back around the sun again in about 7 days and be square on us in about 14. Those are approximate values. And these new active regions that are popping up now are on the equator, which indicates that we are now at the maximum peak of the solar cycle. So being on the equator, and if the flare erupts while it's square pointed towards the Earth will be totally impacted by that flare. Now, it's been my experience, I've been studying this stuff for decades, that you get a new active region, which is very pronounced, which just happened. Then the next rotation, it's usually even hotter. And then the third rotation, each rotation nominally 28 days. The third rotation, it's not as hot, but it spews more and it's more likely to disturb the Earth's magnetic field. So you have two aspects here. You have the X-rays and the proton emissions, which are the direct flare type activities. They're more of a radiation. It disturbs the ionosphere and creates secondary radiations that interfere with microwave, anything microwave or what have you are susceptible. And now that all this China crap technology has permeated everything, we're much more prone to these solar flares than we have been in the past. I do want to reiterate that there's nothing out of the ordinary of this solar cycle. They don't hold this, thus far, does not hold a candle to the great solar flares of 1980, which I referred to with the church music and all of that stuff that was going on at the time. But the technology now is weaker. And so even though the output of the sun is not outrageous, the technology is becoming outrageously susceptible. So it'll be interesting to see what happens. So basically, we'll have about a year of this, and then the sun will start to calm down again and go back into dormancy before it starts the next solar cycle. The solar cycles are taking 11 years. That's actually not correct. The solar cycle is 22 years. 11 years positive magnetic field, 11 years negative magnetic field. So it's like saying, 12 hours in a day versus 24 hours in a day. There's actually 24 hours in a day, but the clock is in half cycles, so it's 12 hours. It's the same situation with the sun. Since the great eruptions of 1980, or I should say 1978 to 1982, solar activity has been pitiful and has actually dropped to a level where there really wasn't enough ionosphere left to support radio communications. And short distance ham radio skip completely vanished. And there is nothing to indicate that we are going to go back into one of these exceptionally intense solar cycles. But I will point out that there were no solar cycles before the Renaissance. So it could be that there might not be any more solar cycles after this one, or there could be a new type of solar cycle that will do something entirely different. So it's just like this climate change thing. The climate changes every day. And the sun's not going to keep doing the same thing cycle after cycle after cycle after cycle, because, you know, time goes negative infinity to positive infinity and anything can happen. So right now makes it interesting, and it's going to be, you know, kind of an anticipatory thing to see when this region presents itself, when it's on the side of the sun and we start to see it come around and we can see what spews out of it, which is really perfect time to do it is when it's 90 degrees off, because then it's shooting out and becomes visible. So it's a very good form of entertainment, and it might produce some rather unusual or undesirable or desirable, depending upon how you look at it. Because I hate digital. So I pray for a solar flare to fry it all so we can go back to normal reality again, because digital truly is destroying the human species and empowering totalitarianism like the human species has never seen in its entire history.
Okay. Let's see, we got a question from Ken B, Sonoma County. Can you, okay, go for it, Ken.
Man, this is really a pleasure to listen to all the different things that everybody's been presented, and Aaron, for you for hosting the call, and certainly for you, Eric, in terms of bringing out your knowledge. I've been following your work roughly off and on for, it's kind of been a little bit sporadic, but probably for at least 10 or 15 years. And I just truly am in awe of the knowledge and the perspective that you put forward. So I don't hit all of these calls, but I hit them where I can. And I've been a little bit prolific in the chat. And just responding, I put a link of a fellow by the name of Ben Davidson, who has a YouTube channel and a website called Suspicious Observers. And he's been following the sun for a long period of time and is basically talking about that everything that we're currently in is leading up to a magnetic pole flip, which of course has happened not sporadically, but on regular 26,000 years intervals to the history of the Earth. And it relates to when the Earth traverses above and below the galactic plane. And so as we're coming on down into the galactic plane, you know, the pole configuration on one side of the plane is north and south, and then the pole on the other side would be south and north, obviously very relative. And so when it traverses that plane, all the magnetic fields goes to zero, and then things kind of get a little bit crazy, but then it restabilizes on the reverse configuration on the other side. And so one of the things that he talks about, and I'm just talking from what I've perceived from him and all of the videos that he has, is that there is a lot of solar activity that increases and becomes more pronounced as we get closer to that magnetic galactic plane. But the real killer is that the Earth's magnetic field goes to zero. And so that this current solar flare, although the actual flare was moderate, we had very pronounced impacts on the Earth, you know, from the aurora and all the various effects, because we had a dramatically decreased magnetic protective field. And when you look at a chart on this thing, and he's got a chart on his website where it goes all the way from, you know, the 1850s and the Carrington event all the way out to now. And I believe it was in 2020 that we reached the inflection point of the decrease of that field, which means we have an exponentially decreasing field from now for about the next projected 20 years. And so, and at which point it goes to zero and then the flip takes place. So I'm not trying to sell Ben Davidson, but I do think that he's got a very interesting perspective on it. And the link I put in there. And then the other thing, and I don't mean to be going on, but it's just, this is fascinating, is the gentleman who was talking about the sun as a capacitor, that I've also been following the work of Nassim Haramein, and who basically talks about all stars and planets and various things within the cosmos are areas of kind of quantum coherency. And so when a location of quantum coherency takes place, it ends up being a portal to kind of like the essence of space-time. And with that portal, there's a tremendous amount of energy that has the ability to both be emitted and absorbed, depending upon the geometry. So I'm not going to get into it too much. I just put a link in there. And I just really wanted to thank you guys for doing what you're doing, because I think it's absolutely phenomenal. And part of my background is helping companies and organizations and groups kind of get consolidated on ideas and marketing and project planning and all that kind of stuff. And I feel like the work that you're doing is really priceless. And the biggest thing that I've found coming into many groups that are, quote, doing great work, whether it's in math or science or law or whatever, is that there's a tremendous amount of information that you're trying to put forward. And yet for the normal new person who maybe understands a little bit about Tesla and maybe they understand a little bit about science and cosmology, trying to put it together in terms of saying that if I was to look inside of the mind of Eric Dollards, I would say that you have a different concept of physics and electrodynamics that most people do not understand. And from there, you kind of derive this massive collection of projects. Every single one of them has amazing value, but to look at it as a comprehensive whole, until somebody can understand that comprehensive whole, makes it very difficult for most people to actually see the true value out of it. And I just want to say, if there's anything I could do on that, I would truly love to be able to support you and assist you in doing that. And with that, I will shut up and yield.
Okay, well, I don't know what you could do because everything's pretty much set the way it is. It's not like I haven't written anything or given any presentations that don't describe these kind of things. So that's the best I can do. I've seen this suspicious observer. I have run across that. There's a number of things like that on YouTube. I usually don't pay attention to those things because everything is usually kind of a Chicken Little that, oh my God, the world's going to end. This is the biggest flare. We're going into this and that. And I don't really pay much attention to any of that stuff. There's no point in it because just with the equipment I have in my car and common sense, and I can pretty much tell what is and what ain't. And there's nothing out of the ordinary right now. There could be, but there's nothing to indicate as such. I think the only thing that will be out of the ordinary is that the technology now is just such garbage that even an insignificant event will just wipe everything out. Otherwise, there's, the sky's not falling. Poles aren't going to shift. The world's not going to come to an end. It's all just kind of normal for now. But
The information,
the
info he presents is compelling, though. So,
well, I mean, you can watch a good science fiction movie and that can be really compelling too. You can watch a movie that'll leave you tears in the end, but it's only a movie. So I don't involve myself with those things too much.
Well, there's definitely plenty to pick from. I mean, if you look at the different presentations, from the seismic stuff to the, wireless transmission, even the Trump motor. There's bound to be something that no matter what somebody's background is, they're going to find something that they can relate to. There's Eric's presentation, the power of ether as related to music and electricity, for example, has a lot of stuff about frequencies and harmonics and music and stuff. And that's, for example, a presentation that's pretty lengthy and it goes into a lot of stuff, but there's a lot of things in there that the average person can relate to, especially if you just look at like Facebook and other social media outlets, what a lot of people who don't really have a strong technical background are into. They seem to kind of gravitate towards a lot of the frequency stuff, even if they don't understand it. But there are presentations like that, for example, and if people want even smaller bite-sized chunks, to kind of learn some about Eric's work, if somebody's more into the electrical engineering kind of part and wants to kind of get their foot in the door, I would say possibly Lone Pine Writings, a common language for electrical engineering. That kind of sets the vocabulary straight, and kind of gives a good foundation for people to look through. There's a more recent book in the last couple of years, The Digital Age. I think that's probably something that the average person can also understand. It doesn't go heavily into mathematics. How would you give a simple synopsis of that Digital Age booklet, Eric? Because I think that's for the layman.
Yeah, well, it's split into two parts. One is the electrical utility in the digital age, and it shows how the whole electrical utility system is being turned inside out with tragic results. And the other one is a revival of the science of electricity in the digital age, which points out, how all this stuff that I'm talking about was actually well understood 120 years ago. And but it's got buried by Einstein is fine. And until now, it's just, nobody has a clue anymore because there's no education. When it gets to the point that a bulk of the population believes that NASA faked the solar eclipse, there is no hope anymore for interaction with humans. That pretty much ends it right then and there. And I want to point out that ultimately, I'm just kind of a simple-minded hick. And I don't have my Texas accent anymore. I wish I did because it irritates the English, and I love to do that. But I didn't come up with any of this stuff. All I did is I went back to the original work and took it apart piece by piece and put it back together. And there's really very little invention on my part on that level. And that's why with the limited amount of funding available, I'm trying to resurrect a lot of these old-time concepts, like the revival of the science of electricity in the digital age. The complete Heaviside book should be coming out pretty soon, which puts everything back straight again. It's basically my life's work that I finally completed, and I have to get out all the transcriptions of Arthur Kennelly's work, which is the basic foundation of transmission engineering before Steinmetz. So that was a very arduous task because the original books don't exist anymore, and the reprints are all, it looks like someone deliberately screwed up the equations. And even in the original books, which I do have some of the copies of, the work was preliminary, undeveloped, and lots of typo errors. So it's probably one of the most difficult projects of my life was to straighten the Kennelly stuff up. So basically that has to be transcribed and put out. But the thing is I don't have the money to pay people to transcribe this stuff. I don't really have the money for much of anything. And, like getting my teeth fixed before they fall out. So I put it out at the rate I can. Right at this instant in time, most of my writing is doing what I normally do, is the two presentations that I gave last year. I'm writing those presentations up and making books out of them. So I work on that every day. And Until I finish that, I can't spread out on other subjects, but I think what I've written thus far, like the Lone Pine writings, is that really cleans a lot up as to what the language of electrical engineering is. And then there's an extensive YouTube video which has been nicknamed The Theory of Anti-Relativity. I think it's called the Theory and History of Electricity. It's got like 1.2 million views, and that's on YouTube. Not that YouTube will make it easy for you to find, but it is there. It usually does come up on the top. That was a monumental effort to completely hit the reset button on the understanding of electricity. It took months to produce that. And then there was a couple of presentations I gave that were of the same magnitude. One was the history, theory, and practice of the electrical utility system, which was almost 6 hours long. That basically is a complete college course on electrical engineering from beginning to end. And then the master's degree element of that presentation is called Electrical Transmission and Multiple Coordinate Systems. So basically, I've rewritten the whole of electrical engineering thus far, and it's just a matter now to get the tail end of it out and published. But I don't know if people are really interested in any of that anymore. Is all this stuff now is all people want is a new drug now, and that's it. The only thing they can do is peck on their silly phone. And like I say, if they believe that NASA faked the solar eclipse, well, then we're finished.
And so some of Eric's books, besides emediapress.com, where these presentations Eric mentioned, they're available as paid digital downloads. On amazon.com, you can also go there and type in Eric's name, and there are a handful of books. I don't know, there's maybe six or seven of them or something like that. They're the Versor algebra books, the Digital Age, and a few others. And then also throughout the call and many other calls, Eric has this terminology, gain green energy. And if anybody wants to know what that is, gangrene is like an infection in the flesh, right? So gangrene energy is all the dirty electricity and the noise, like all these LED screw-in lights, they have all these high frequency power supplies and stuff inside of them. And these are putting all this noise and everything on the line. And so the so-called dirty electricity, that is what Eric's referring to as the gain green energy. I thought we did one short presentation on that at the old shop here in Spokane, Eric. That might be on my YouTube channel. And I know it's been mentioned in some of the other interviews, but I think the next episode in June, when some of the guys are down there, you're going to expand on that, right?
Yeah.
And so, but that's what he's referring to when he talks about gain green energy.
I completely understand, what you're saying and what you're presenting, and I absolutely agree that, with the collection of various videos and things that you've done, you you effectively have rewritten electrical engineering, and the fact that nobody, quote, the rest of the world gives a hoot because they're all playing along with their digital whatever they're looking at is their loss. And yet I also realize is that at some point, I mean, there's always a small collection of kind of wild hair researchers and enthusiasts that love this kind of thing. And some of them, I followed this guy, Master Evo, on YouTube for a while, and then there was another guy, the old electrician or the old scientist, this old scientist or something like that. And they're all doing all this kind of reinvestigating, scalar waves and Tesla transmission systems and all these different things. And I like, man, this is fantastic, because there's actually people doing that work. And so somebody even mentioned whatever that site is for Give, Send, Go, for fundraising. And I figured, obviously the entire body of your knowledge is what, 50 or 60 hours worth of presentations. And you've tried to put a good portion of that on YouTube. But for somebody to really look at it and said, well, what can he give me that I can at least get a picture of within an hour and a half? And starting with the basic premises of how electricity in your mind is different than the way most people understand it. Inductive and capacitive coupling and how those two different things work, and the Versor algebra and all this other stuff. And when somebody, at least for myself, when I look at the body of your knowledge and say, your fundamental thinking of electricity understands the current world, but it's a heck of a lot deeper. And because it's so much deeper, you can bring out anomalies that most people throw away. And yet the gold is in the anomaly of what people are not understanding the true fundamental physics of. And so obviously what I feel like that I would need to go do is to look through a lot of those things and then in my own mind say, can I simplify this stuff down to either a simple set of links or a simple set of concepts that gives send go newbie can walk into and say, oh my God, if we really implement this guy's system, we can have an entirely different world. And from what I see, that's a fact, but nobody gets it. And that's the sad part. And I've seen this exact same struggle take place with Nassim Harriman, with Ben Davidson, with all these other people. And I'm not trying to sell any of them, but until they can boil down their physics into a step 1, step 2, step 3, step 4 little progression, and unwinding the bullshit that comprises what's in most people's mind, they don't go anywhere. And that's what I try to solve when I come into a group that has what I consider to be a gold mine, but an undifferentiated way of presenting it. And so it always comes down to a value proposition. The value proposition we have in this world that we're in is get lost in the details, find some new silly little app, and the next big solar flare, we're going to be back to primitive times. On the other hand, there's different ways we can look at it. And I can't really offer a lot right now until I get my own background work done. But I just want to say I see so much tremendous value in everything that you guys do, from your Borderlands to Peter Lindemann to all the way through it. And I've just been in freaking awe because I got introduced to this field in 2020 with Nassim Harriman and Mark Cummings and a bunch of other people, and Peter Lindemann and Eugene Malov and all these other bigwigs back then. And I've kind of just been trying to sporadically stay on top of it all the way since, and also seeing how so many of these brilliant people have just gotten destroyed. And it's like, I don't want to be witnessing that if I cannot try to support it in some way possible. I yield.
All right, appreciate that, Ken. Well, do you have a comment on that, Eric? Or we're getting on 2 hours. We can probably get it
Yeah, I
wrapped.
can. Well, the thing is that these people that you have mentioned basically all have a very one-dimensional view, and that's part of the reason why it doesn't really go anywhere, because it doesn't have a fundamental archetype. It doesn't tie in directly. It's this idea or that idea, and then things become fads like the Soviet scalar wave conspiracy, and then free energy secrets. And finally gets to a point where it's just completely nauseating because there's nothing there, bunch of harebrained ideas and what have you. So there really is no easy way out. You can't just take a hit off the pipe and then all of a sudden become enlightened. It doesn't work like that. You have to do all the groundwork. If you don't have a good knowledge of mathematics, if you don't have a good knowledge of dealing with the physical world and basic dynamics and the fundamentals of nature, then it's not going to be understood on any level because you don't have the language. That's the first thing you have to do. You have to have the language. It's not just something that, you pop a pill and all of a sudden you've got it. You got to do your homework. You got to get the language down. That's what I tried to do with the Lone Pine writings, but for somebody that's, completely unversed on any of this type of stuff, even that is going to be an impossibility. So somehow, I don't know, because there's no education system anymore, you're not going to get any of this stuff out of any university. University actually takes you back the other way. All it is just a bunch of ritualistic rites of passage for some useless mathematics that makes things so complicated that nobody could ever possibly understand it. And then you're expected to understand something that you can't possibly understand, and unless you're some kind of freak that can make sense out of nonsense, then you don't graduate and skip all that stuff. So I don't know, with no education system, I don't know what to suggest, or there's areas, you got to go back to all the old stuff. You got to get like a 1920s, 1930s ham radio book and build some things and experiment and what have you. But, I've been doing this stuff since I was 6 years old, 1958. And only, I would say, in the past 10 years has everything kind of finally come together into some unified aspect in my mind. So that right there tells you that it isn't something you're just going to pick up in a couple of weeks, and you're not going to get it off of any type of one-dimensional presentation. So it's a dilemma. I don't know, how anybody could get instant gratification out of a situation like this, not alone turn it into anything, that would make a lot of money or allow this project or projects related to happen in a reasonable period of time. And then you have to ask yourself, how much longer is this society going to last before this scientific totalitarianism and digital dystopia makes it where it's actually illegal to even talk about stuff like this? We're already reaching that level. And then most people, all they want to do is peck on their silly phone. They don't care about anything. The world's flat. Chemtrails are killing us. We never landed on the moon. And now NASA faked the solar eclipse. It's hopeless. So I think I end my rant on that. It's hopeless. So basically the way I portray it, in my situation, it doesn't matter how many times you kick the coyote in the head, it's still going to eat your chickens. I just do what I do, just like a coyote does what it does. I don't care what kind of rewards. I don't care what kind of trouble it makes for me. I don't care if anybody likes it or if anybody doesn't. I've been doing it when most kids were still in their cribs shaking their rattle, and that's what I'll do until the day I die.
And if you want to support those efforts, go to ericpdollar.com and there's a donate button. And anything you can help with by PayPal would be appreciated, or sending checks or money orders. Again, it's EPD Laboratories, Inc. is a 501c3 charitable nonprofit. Donations are tax deductible, and that helps to further these projects. And with some of the pictures that you saw on the screen, and so, a lot of the past calls and presentations, you can see that the donations go exactly where they're intended, and that's to further the science in these furthering the science of electricity. And we're doing a lot of things that nobody else is showing, and at a scale that's nobody else is replicating anywhere in the world, except for at EPD Labs. And again, as far as anything that the public knows about. So ericpdollar.com, and I'll put subtitles on this, and I'll get this up on YouTube when I can. I probably won't even edit it. I'll just put a title screen and an ending screen and slap some website subtitles on there and call it good. So I think until then, any final word, Eric?
Well, yeah, one thing, when I get sometimes I get substantial donations from somewhat anonymous people, And I'll write them back and I'll ask them, well, what is it that you're interested in that you're giving this much money for, so that I can optimize it, so that with the money spent, I can orientate things towards your interest. Well, they never respond. And then, as we've seen, people ask, what can I do to help? How can I this and that? Well, basically, unless you can climb utility poles and drag wire, or you can, punch chassis and wire, patch panels, you can't really help. But one way people can help is obviously individually amongst us presently. No one really has a lot of money, particularly in today's economy. Nobody has any extra money on our level, but there's people that do. There's people that have loads of money. They got more money than even know what to do with. So if anyone wants to help, it's not, you spend your, half your beer money that you're pinching, before the 30th of the month arrives for a donation, would be to find somebody that does have the money. That's the help that we need, is to find people that do have the money, that would put it into something that's purely scientific like this. That's what we really need, is that level, because otherwise this is such an expensive project that, and the tragedy is I've already built all this stuff several times and it's just been destroyed. And on top of that, I was basically, the master of priceless installations like the Bellina station, which just got taken over by the scallywags and turned into a freak show. Another one's the Integratron. The Integratron was a very important project, even though it might sound goofy with the Space Brothers and the channeling, but there was something there that was engineered, and it just got taken away and just became a self-worship temple of the same people, and the degradation of all of the work that went on. And now I'm supposed to do it all over again in a society that doesn't give a damn about it. There's no more RCA, there's no more Bell Telephone, there's no more US Navy, there's no more LA Department of Water and Power. All the support is all gone. And now I got to do it all over again. This is what I'm up against. And I don't have another 30 years of my life to build something just to have it bulldozed when it's done. So I think I'll conclude on that.
Okay. Justin, did you have a comment?
Yeah, I wanted to just chime in here at the tail end and say thanks everybody. Thanks for all the participants and the questions. And I've been reading the chat. I haven't responded in the chat, but I just wanted to acknowledge what people are saying in the chat in regard to, there were some suggestions about an Indiegogo, GoFundMe, Patreon. There were some suggestions on how we can raise some funds for the project. And I want to acknowledge, thank you everybody for those suggestions. And one of the things that was specifically asked in the chat was, do we have a concise presentation, end-to-end diagrams of how all these facilities tie together, like as I was referencing earlier, that they do all tie together. And so we do have some historical documentation. We have some things that can be compiled and basically re-released. And we're also intending in this upcoming session to get more concise and document those things. So I think it's a good point that people have put forward, that's really what we need, is a sort of a concise documentation end to end. And we will be working on that, as well as trying to produce maybe an even more in-depth presentation than we presented previously. We'll be working on that upcoming. That's basically all I wanted to conclude with. Thanks, Aaron.
And Justin, don't we have some of those documents in PDFs that may have been put on Eric's website in the free paper section or somewhere? Because I know there was some that were, not for the public, but then there were, but some of those summaries basically kind of spells out in diagrams exactly what we're trying to do. So that's all that stuff already exists.
It does. Yeah, you're right about that. And that's one of the things Eric and I spoke about recently is, later when we're off this call internally, we will, we'll talk about how we get that stuff up on the website and maybe kind of even re-highlight some of the work that's been done previously that we already previously released that maybe folks just don't know about.
Sure. Okay. Yeah, we can get together and talk about those. Okay. Well, I guess we're going to go and wrap up the call. It's been 2 hours and 8 minutes here. A lot of good questions and everything. Thank you, Eric, and everybody else for joining the call, and for Griffin and Connor and Justin with what they've shared on the call. We'll probably schedule another one for about, I don't know, another 3 weeks or so. Usually Dr. Adrian Marsh is with us on these calls. He's busy with some work projects, so he wasn't able to join us this time, but we'll send out the announcements in both my Energy Times newsletter and also on Eric's mailing list. And so until then, we'll see y'all next time. Okay, thanks, guys.
Thank you,
Talk
everybody.
talk to you later, Justin.
Okay, bye.
Okay, see you, Eric.
Yep.
Thank you.
Have a good weekend
You.
and good Memorial Day weekend, everybody. Take care.
Happy birthday, Eric.
Welcome.
And Eric, by the way, I did announce your birthday in the newsletter, and
Okay.
I think that those maybe $500 or $600 came in PayPal.
Oh, well,
So that was
birthdays are actually worth something.
yeah, it was a good one. So
I just look
Okay.
at it as I'm 1 year closer to death, so I never celebrate a birthday.
okay, see you guys.
Okay, thanks.